Okay, let's take a look at what happens when gas gets absorbed into liquids. Now this is a subject where you often see instructors waving fizzy drink cans in front of their students to demonstrate that bubbles can occur when the pressure is released from the can. Now it's a great demonstration. It shows that there is gas in the liquid, and it also shows that the gas can come out in a dramatic way. But when you go diving, instead of cola and carbon dioxide, it's more about your blood and nitrogen. Anyway, how does nitrogen get into your blood in the first place? So we'll be taking a closer look at what happens to liquid when gas is forced into it. We'll also take a look at some of the words that PADI might use in their questions. Well, actually in their answers as well, come to think of it. So we'll take a look at the particular jargon that you're likely to come up against when you're looking at this subject. So naturally, the more that you can understand this subject, not only will you be able to get higher marks on your PADI exams, but once you are an instructor, you'll be able to pass this information over to your own students in a really simple way that they can easily understand, whether or not you've got a can of fizzy drink in your hand or not. So let's take a look at a typical PADI type of question. You may remember seeing a question like this before. It's about a glass of water that's sitting in a recompression chamber. The question then goes on to ask what's going to happen if the pressure surrounding the glass is either increased or decreased. Now, if you're not really too sure of this subject, then when you start looking down at those multi-choice answers, you might get even more confused, because this is where new words can sometimes start to crop up. For example, instead of continuing to use the word water or even liquid, the answers might start to use the word solution instead. Other words start cropping up as well, like pressure gradient, saturation, supersaturation, equilibrium. All these words start to creep in. So what we're going to do is take a very simple look at what's going to happen to the water in the glass when gas is forced into it, and we'll also discover what these other words might mean as we work our way through. Of course, the water in the glass is simply H2O, hydrogen and oxygen. But for now, we'll concentrate more on the air that's surrounding the glass, which is, of course, made up of nitrogen and oxygen, and mostly nitrogen. So, as the pressure in the chamber is increased, small amounts of gas from the surrounding air is then forced into the liquid. So already we've got one answer to a common PADI type question. It could be a true or false question. True or false? Gas will get absorbed into a liquid if the surrounding pressure is increased. Now, the answer obviously is true, but we still need to be aware of tricky words or word changes that might crop up, because when we start to think of it, once the gas has been absorbed into water, then strictly speaking it's not water anymore, is it? It's not H2O, it's not hydrogen and oxygen. It's got nitrogen mixed in with it as well. So sometimes the word solution is used to describe the liquid. As far as the question's concerned, it doesn't change anything. It's just another thing that you need to be looking out for. Now, the higher the pressure, the more gas gets absorbed into the solution, although it will still look just like an ordinary glass of water. Actually, this behaviour describes your body when you go diving as well. The liquid is your blood, the gas is, well, whatever you're breathing. So let's say you're breathing air, then nitrogen and oxygen will be constantly in contact with your blood in the alveoli in your lungs. And as you descend, the pressure around you increases more and more, and the gases next to your blood in the alveoli get absorbed. The deeper you go, the more gas gets absorbed. Your body will use up the oxygen, it will metabolize the oxygen, but the nitrogen is an inert gas, and this means that it doesn't react with anything. So it just builds up in your blood and gets distributed to other parts of your body. Now, in the next section of this course, which is physiology, we're going to take a closer look at what effect this nitrogen has on your body. And then in the RDP section, we'll take an even closer look at what happens when nitrogen reaches different parts of your body and leaves different parts of your body. And this knowledge helped PADI to form the Recreational Dive Planner. But for now, let's get back to our simple glass of water in the chamber. The pressure's rising, the gas is being forced into the liquid. The higher the pressure, the more gas goes in, just like when you go diving. Now, looking more closely, and we'll see some of the other words that start to crop up in PADI questions. So we did have a glass of water, or a solution if you like, that took on gas. Now it's full of absorbed gas. And as it's full, we can now call it saturated. On one hand, the gas is being held into the liquid by the surrounding pressure, and on the other hand, no new gas can dissolve into the solution unless, of course, surrounding pressure is increased even more. Then gradually it will reach a new higher level of saturation. Okay, but what happens when the pressure surrounding the glass starts to come back down again? Well, as the pressure reduces, gas will start to come out of the solution. Bubbles will start to appear. And here is where we come across these new words, this new jargon that's really common either in PADI questions or in answers. You know, the words pressure gradient, supersaturation, equilibrium. So to get an idea of the meaning of these words, what I'll do is I'll use them now to describe to you what's happening with the gas which is in our solution and the bubbles that are now forming in our glass. So I'll use those words. So here we go, here goes. Before, the liquid was saturated with dissolved gas. The gas was at the same pressure as the surrounding pressure. But when the surrounding pressure was reduced, it caused a pressure gradient between the dissolved gas and the lower surrounding pressure. This led to a state of supersaturation, where the gas is now trying to get out of the liquid. It's trying to escape the liquid in order to reach a state of equilibrium, which is where the pressure of the gas is the same as the surrounding pressure. Okay, so that's using the words with the analogy bit, you know, the bit about the glass in the pressure chamber. But I'm going to continue to use out these words, but this time to talk about you when you go diving. Because as you start to ascend, the surrounding pressure decreases and the dissolved gas in your blood will want to come out. You will have reached supersaturation and bubbles are likely to form. Now, if you ascend very slowly, then it keeps the pressure gradient between the dissolved gas in your blood and the surrounding pressure small, and gas can safely be eliminated within acceptable limits. The gas is trying to reach a state of equilibrium where it's going to be at the same pressure as the surrounding ambient pressure. Now, technical divers, they often have a lot of gas dissolved in their blood. They will often put in decompression stops into their ascent to keep that pressure gradient small and allow gas to escape safely. Okay, so that's about it. Now, I've added some questions for you all about all of this in the next section. Now, try not to get super saturated with it because that might mean that some knowledge might start to leak out, but hopefully you'll get used to know how certain words are used, and you'll also get familiar with the way that gas interacts with liquid whilst under pressure. Oh, by the way, all of this is called Henry's Law. I'm really looking forward to seeing you in the next video.